Locate the absolute extrema of f of x equals sine of x times cosine of x on 0 to 2 pi exactly using analytical methods. So we're going to use the procedure for finding absolute, maxima, and minima. So the first thing I need to do is find the domain. Normally the domain of this function is all real numbers. However, I have a restriction. So the domain is going to be 0 to 2 pi in this case. The second thing I need is the derivative. I'm going to use the product rule to find the derivative. So f prime of x is, if I take the derivative of sine of x, that's cosine of x, and then leave cosine of x alone, plus the reverse. Leave the sine of x alone, take the derivative of cosine of x, which is negative sine of x. So this derivative is cosine squared of x minus sine squared of x. Okay. Then we want to find the critical values. So that's going to involve setting the derivative equal to 0 and also locating any places where the derivative fails to exist. So first of all, derivative equals 0. So if I have cosine squared of x minus sine squared of x equals 0, first thing I'll do is add that cosine squared to the other side. So cosine squared of x equals sine squared of x. And then, because sine and cosine are tough to solve by themselves, I could divide that off, get tangent. It's going to be a lot easier to solve. So 1 is equal to sine squared divided by cosine squared. And since that's tangent, I have 1 equals tan squared of x. I don't want to solve tan squared of x, of course, I want to solve tangent of x. So I'm going to square root both sides. Plus and minus 1, square root of 1, is equal to tangent of x. Now in the unit circle, if I'm looking for places where tangent is equal to 1, I want my sine values and my cosine values to be equal. And if I want plus or minus 1, it's going to give me all those pi fourth multiples. So it's going to give me x equals pi fourths, x equals 3 pi fourths, x equals 5 pi fourths, and x equals 7 pi fourths. All those pi fourth multiples will divide to negative 1 or 1 on the unit circle. So those are my 1, 2, 3, 4 critical points so far. I want to check for any places where the first derivative fails to exist. Sine of x and cosine of x are both continuous functions, so they're always going to exist. There are no denominators in them to set equal to 0, so there are going to be none. Always check for it. If your function is continuous, you may not get any. Okay, so we're on to step 4. Step 4 is where we evaluate the function f at the endpoints and at the critical values. So let me label these. By the way, these are our critical values. We have 4 of them. Okay, so I'm going to take f and evaluate at the endpoint, 0. Then f and evaluate it at pi fourths, f at 3 pi fourths, f at 5 pi fourths, etc., f at 7 pi fourths, and f at 2 pi, the other endpoint. So we need to plug all of those into our function. So I'm going to do that on Desmos again. Wrong button. There we go. Okay, the function is sine x times cosine x. Let me get that to work if the function's not working quite yet. There we go. I just didn't understand the implicit multiplication there. Okay, and I want to plug in 0. I want to plug in pi fourths, 3 pi fourths, 5 pi fourths, keep going, 7 pi fourths, and 2 pi. Okay, so we have f of 0 is 0, f of pi fourths is half, 3 pi fourths negative 1/2, 5 pi fourths positive 1/2, 7 pi fourths negative 1/2, and 2 pi, we're back to 0. Again, those were plugged into the original f, not into the derivative. All right, so when I'm looking for absolute extrema, we're looking for the biggest and the smallest. So our 2 negatives are the smallest, and our 2 positives are the largest. Okay, so we're going to have 2 of each. If their y values are equal, they're going to be more than one absolute extrema. So we have, we'll do the minima first. So we have 3 pi fourths comma negative 1/2 and 7 pi fourths comma negative 1/2 are absolute and local minima. Now, this test is only checking for absolute. I happen to know that they're local because they're at interior points, but I can't check those yet. And the other 2 pi fourths comma 1/2 and 5 pi fourths comma 1/2 are absolute and local maxima. And again, I only know they're local because they're interior points. So let's check. We got it right. That's a max. And so is it at pi fourths. And our 2 minima are at 3 pi fourths and 7 pi fourths. So, good.